Hello, and welcome to this lesson in quantitative reasoning. This is the fifth of 5 videos on set applications, basically dealing with things like subsets and proper subsets and types of sets, whether they're infinite or finite. We've looked at that in the prior 4 videos. This is the 5th one. So what we're going to deal with today mostly consists of how do you know how many subsets you could create and how many proper subsets you could create from a set. So, and it turns out quite simply, it's a pattern that has a formula that depends on the number of elements in the set. So how many could I write? So the first thing we want to talk about is the empty set. The definition of a subset says it has only elements that you see, but may not contain all of the elements. In fact, it may not contain any of them. You can have an empty set. If I give you a list 1, 2, 3, the empty set is a subset of that set. Because it's not there, you can't say it's not there. It's there. I know that's a little weird. I know that's why we don't always like this kind of math, because it's abstract. But let's make a rule. We like math. We like rules that the empty set is a subset of every set. So we know we have one subset, which makes sense because the empty set itself is a set and it would be a subset of itself. So the empty set is a subset of every set. So that's one. And we also have seen that a set equal to our set is a subset. It's not a proper subset, but it's a subset of that's not proper of every set. So you can have a subset that contains all of the elements in your original set, or a subset that contains none of them, where we call that the empty set. And then there's a whole bunch in between. So how do we figure out? There could be a whole bunch in between. How do we figure out how many subsets there are? For smaller sets, you could write them all out. But there's a pattern so that you can even figure it out for a larger set without having to write out every single subset. So the empty set is also a proper subset of A because it has less elements than A. So we're working with the set A and talking about subsets of set A in this video. So this means at least one element of A is not in the proper subset. So if you're talking about the empty set as a subset, none of the elements are A, so it is a proper subset. So not only is the empty set a subset, it is also a proper subset. That's a rule you have to remember. And you'll see this is when we write out some subsets, you'll see that the empty set is a subset of each set, and it helps fit the pattern. So here is the rule. The things in big yellow boxes in your text and in these notes are rules, things you should know. And I think this might even be in your vocabulary sheet. And a set, and this also points out what I said before, a set is always a subset of itself, but it's not a proper subset. So how do we count the number of subsets? So we're going to start with the set A. That's just the numbers 1 and 2. So the possible subsets of A are, well, if I had just the number 1 in a set, it would be a subset. If I had just the number 2 in a set, it would be a subset. So there's that one, there's that one. The empty set is a subset, and every set is a subset of itself, so I write the whole set out. So when A has 2 elements, and we say that means n equals 2 for our formula, there are 4 possible subsets. Now, here's my question. How many of these 4 subsets are proper subsets? Well, it turns out whenever you make a list like this, you're going to find out that you always have there's one that's not proper. The set containing 1, 2 is a subset, but it's equal to A, so that one is not a proper subset. So there are 4 subsets and 3 proper subsets. And that will always be the case. You figure out the number of subsets first and then subtract 1, because one of those subsets will be the one that contains everything, and that's not proper. So once you have the number of possible plain old subsets, the number of proper subsets is just 1 less. So there is a formula here. So if you continue this process, when a set has 3 elements, there are 8 possible subsets. If A has 4 elements, turns out there's 16. If A has 5 elements, turns out there's 32. There's a pattern. In general, and this 2n is not correct. It should say 2 raised to the n subsets for a given set A. So A is a subset. The yellow box is correct. So what does the raised n mean? So if I have 3 elements, so n is 3, 2 to the third. This is not 6. That's the biggest mistake students make with this. This is very simple, but you got to remember that's 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8. You multiply, you write down the number 2, the same number of times. You find the number of elements you have. Write down the number 2 that many times and multiply them all together. That's 2 to the nth if n is the number of elements. And proper subsets, you would just subtract 1. So with 3 elements, you have 8 subsets, and you have 7 proper subsets. So you would answer this question, wow, this 1, 2, 3, 4, 5 elements. Now, if you had to write out all of these subsets, that would take a long time. So this formula is a shortcut. You do 2 to the nth, 2 to the fifth. So if you multiply 2 by itself 5 times, you get 32. And in your calculator, there's usually a button that looks like a caret, like that. You could do 2 to the fifth. You might have a button that looks like y to the x. Make sure you can do 2 to the fifth in your calculator and get 32. This is about the only thing you need a calculator for until we get to the finance unit. So in this unit on sets, really, this is the only reason you need a calculator, if you can't do 2 to the third, fourth, or fifth power without one. So 2 to the fifth, wow, that's a lot of subsets, 32. I don't want to have to write all those out. You could, but the number of proper subsets is just one less, because even though there's a lot of subsets, only one of them is going to look like this, and that's the only one that's not proper because it contains all the elements. All right, I want to go through a little exercise and write out all the possible subsets for a set that has 3 elements. So I'm going to make a blank slide here. So let's make a set B. B has the numbers 6, 7, and 8. And I want to write out all the subsets. So first of all, from the pattern we saw, there are 3 elements. So n equals 3 elements. So from the pattern we saw, we know 2 to the third is 8. We should get 8. But let's write them out. So the first one is the empty set. And I can write that in my, remember, we have to write sets using braces. If I don't have those braces, this B is not a set. You have to have the braces. So that's one. And then there's the set that contains all the elements, 6, 7, and 8. So that's a subset. And then there's this set that contains each one of them individually. Oh, sorry, I wrote 6 twice. That should be a 7. And this should be an 8. Then there's the set that contains 2 out of the 3. So that's a little trickier. So I start 6, 7, then I do 6, 8. Then I go back, start with the second one, 7, 8. So I leave out, when you're taking 2 out of the 3, what you do is taking turns leaving out 1 each time. I left out the 8, then I left out the 7, then I left out the 6. So if I count these, 1, 2, 3, 4, 5, 6, 7, 8, sure enough, there are 8 subsets. And that's the same thing I get if I do 2 to the third. That's 8. Now, proper subsets, I need to cross one off. So this one right here is not proper because it has all of them. So there are 8 minus 1 is 7 proper subsets. So that is an example of writing out all of the subsets that shows you this pattern does indeed work. If I had to do this with 4 elements, it turns out everything, if I had 6, 7, 8, 9 in another set, and I wanted all the subsets of that, turns out everything I've written here, all of these things here, would be on that list. But then I'd also have to have the list that had all of 6, 7, 8, 9. And I'd also have to have have just the element 9 by itself. And then I would also not just have the sets of 2s, I would have to have a 6, 9 and a 7, 9 here. And an 8, 6, 9, 7, 9, 8, 9 in the 2s. But then I would have to make a list of all the subsets that were of size 3 if my original set was size 4. So I would pretty quickly get to 16 subsets. It seems like you should just be adding like 1 or 2 but you actually double. Every time you add an element, you double the number of possible subsets. You always find the number of possible subsets first, and then to find the proper subsets, you just subtract 1 from that. Okay, so here's another one where we're not dealing with a set full of numbers, we're dealing with a set full of months. How many proper subsets does the set M containing the months of the year have? Well, we know there are 12 months in the year, and we don't want to write out all those subsets. So the question here, too, is proper subsets. So you can either remember that the formula is 2 to the n minus 1, or find 2 to the n first, and then subtract 1 from it. 4,095. That would be a lot of subsets to write out. So aren't you glad you don't have to write them all out and hope you found them all in order to find out how many there are? You want to use this formula. So hope, it's an exponent. You're supposed to know exponents to be in college math. Hopefully that's not the hard part. If you have trouble finding how to do it on your calculator, drop me an email. Let me know the calculator type. I'll help you figure that out. Okay, so that is the final video for that section on set applications. Hopefully you have enough information to go off and do your practice problems and learn what you need to learn and be familiar with the symbols and be able to do things somewhat expediently. Email me if you have questions, and I'll see you in class.